Alright guys, so if you know anything about LHT performance and followed us for any kind of length of time, you'll know we are a big fan of the Jackson Racing Supercharger, especially on the B Series. This is something we have been involved in a long time. We've pushed the envelope, we've produced many parts, and learned so much over the years and hold some of the highest horsepower records on the M62 Supercharger. We have been teasing this project for a while, and I don't mean to tease it, it's just because it's been in the wild for so long, but I wanted to show you the Billet S tube. So there's many aspects of the design here. Most of it is of course for improved airflow. We've done a lot of playing over the years, a lot of port work and a lot of dyno tuning, playing with some of the sheet metal S tubes used to make back in the day. They were very hard to produce and crude, I must say. When they were done, we did maybe a handful, including the one that was on the CRX that was on my car. Often on this setup on different platforms, something is compromised. It's very tight. The idle valve, the TPS, something gets in the way of something. It's a very short, stubby design. We have increased airflow by porting this, and often cases cutting it open and changing the shape. You can see some of the casting designs here, but you can see basically the floor, or the roof as we call it. The airflow hits that, and then you have a big void over here. I'll show you some more on that with the airflow analysis that we did. And this one is designed to eliminate that. There is basically no floor, and it's a much straighter design. This is a 70mm. There is room to go larger. As you see, we left a little bit of material. We can go to about a 74mm, but from the testing we did, most of it is airflow restriction, is not the diameter, it's the shape. We played with some on a flow bench as well as dyno tuning. We went all the way to a 90mm throttle body, and once we got to a certain airflow, there was no change, because of course you've only got so much room here. The Supercharger can only ingest so much air. Once you take the restriction out, you've essentially equaled zero airflow restriction. So this is our design, and it's finally here. I mean, it's exciting because it's been in the works for a long time. There's a lot of design, a lot of time, and of course, when it comes to the machining, how much time has gone into not only the tool path, but actually how do you mount this to cut it from every different direction. I mean, look at this thing. It's absolutely beautiful. So we did keep these in the same place. We're just waiting for those. They will be pressed in. It'll be the same as this. So we did keep those. Of course, you need one of them for the bypass valve, which is, of course, in the exact same location. It basically fits back the exact same way. As you see, it fits the same, but it has more room. This area here where it's tight on this model, this gives you so much room around that bypass valve, and you can actually get to and service that valve if you need to with this S tube as opposed to this one. So you can see here, this is the factory piece, how it attaches to the Supercharger. It's pretty tight around those studs right there to get the nut and the bolt in there. It's very tight. So there's been a lot of areas that we want to improve on by building this. So the Billet one, it fits, it has the exact same shape, but there is more room around those studs to access. Much more room. You can get the wrench in there, you can get the socket in there. Much better, much cleaner. And you see how much of a straighter shot it is right to that Supercharger. Much cleaner, much smoother. So not just the concern of airflow, but fitment was very important. Not just to fit, but to fit better. So as you see, we have more room around the hoses by positioning the throttle body also on the angle. It was not only to increase airflow, but for the intake, this intake tube, rather than being straight and having to make such a tight 90, now we can actually promote this into a 45 and bring the intake tube around to the position that we need it. So the idle valve is designed to work for all of the idle valves. It's drilled for the early ones and of course the later ones. The position is actually tucked in a little closer to the motor, about 6 millimeters. The whole thing is actually slid forward about 15. By doing this, we can actually get more room around this TPS. Certain platforms, the TPS would be around here and get in the way of water lines. Now we're actually pulling it in and further away. It gives us a bit more room. Now this is our 70 millimeter throttle body. This is actually made to 70, but there's enough material that you can port it to about 74 and still be comfortable. We've found the size of the intake to the supercharger, there's no increase in airflow by going larger here and larger throttle body. The key is to reduce pressure loss. That's all in the design of this S-tube. Now, our throttle body actually has the pulley designed in a different way. That way, this cable can pull from the right direction and it gives us more room. Again, this cable isn't pointing straight up in the engine bay. It's actually pulling on about a 45-degree angle, which gives us much more hood clearance. You can see in relation to the distributor here, this is in its natural shape right here. It's not pointing up, it's not going to interfere with the hood. It can make a nice gradual curve here and hook up to the factory location. Now, this throttle body, the package comes with the throttle body, the bolts, the gasket, the billet bracket, and the cable. It's an OE cable. It's modified to fit this application, and it gives you all of the adjustment that the factory cable had. So this is the way you would be used to looking at this engine in a B-series application. You can see how tucked in that throttle body is in relation to the manifold. This might give you a little bit more clearance on certain platforms, but the intake is going to be much easier to make. This is in the direction that we need it. Typically we come around here and build the intake and put the filter in the location around here or run it into a cold air behind the bumper. But this is designed to make this a much more gradual sweeping path. Now, the emphasis here is airflow. We're trying to reduce the pressure drop, which we'll show you in the data later. The idea is the supercharger wants to draw air with as little restriction, little turbulence as possible. That's where we get the increased quality of air, more airflow, less restriction, more boost. This is an unported S-tube. You see most of the surface is this roof area here. As the air is drawn in, most of it is bouncing off this area here that's like a wall. It pushes this down, and then we have a huge void over here. This is almost a straight shot. If you look directly down there, it's almost like a perfectly straight tube. This is what increases the airflow and of course reduces the restriction. When designing these and doing the testing, we have countless models. This is obviously a very tiny one. This is again to play with air direction and play to get different aspects of airflow and show the difference and how the air reacts. What we found is even on the small scale, large scale, the air performs and does the same thing. Now you would think typically it would just increase exponential, but it doesn't. It changes when the sizing is actually altered. So there's a lot of airflow changing from this dimension here to the raised roof, right, as you see on this 3D model. So this billet tube has been in the works for about 7 months now. There is a lot of design, not from just airflow to fitment to the actual ability to machine it. Now, we're proud to say this is 100% made in the USA. It's made by the same CNC shop that builds our master cylinder braces, battery ties, and even this aluminum bracket here, which is for our throttle body. We're very proud of that. We want quality. We're not looking for the cheapest option here. We're looking for the best option, the best quality part. As you see, that is absolutely beautiful. So this is the first one. Now the digitizing is figured out, the tool path orientation, and of course right down to the fixtures. How do you hold this? I'll find out exactly, but there is a lot of hours in the machine process just because of the different applications and different positions it has to be put in to do various cuts. I'll share that in this video, but this is the first one. We're going to do a little bit more demo with this, a little bit of testing. We're going to put this into production in about a week from this video. This coming from one solid billet chunk. The material itself is expensive. There's a lot of cost in the design, but we're going to try and keep this reasonable. I am going to keep one for myself. We have a future project planned. If you watch our videos, you might see some things in the background that might give you a clue of what is going on in the future, but I will be keeping one for myself. We'll include all the information here. I want to put more data flow analysis in the end of this video, so if you're into the nerdy part of it and want to know, I learned so much from being a part of this project, but there is some information in there if you are interested. And again, the throttle body package is already available in our site. It's the throttle body, the gasket, the bolts, the bracket, the cable, and it's designed to make your install on your B series supercharger much cleaner. And it is a full 70mm throttle body with a steel pulley. It's not going to stick. It's not going to give you problems like the billet pulley there. It is steel. It does have a proper adjusting screw, so it can be adjusted. But more coming to this. We'll do some more testing, and we'll include all the information for that S-tube, and it will be on our store. Okay, so we have a ton of data on this. I'm not going to bore you too much, but I do want to share a little bit of the information right here, from obviously the design to the airflow and how it reacts through the air going through it. So this is something I wanted to show you first off. This is pressure drop. This is basically pulling a vacuum through the factory S-tube, showing you actually how much pressure drop and resistance there is. So you can see on the stock tube right here, the stock S-tube with the 70mm throttle body, which obviously isn't any large, it's much larger than the actual cast hole, but you can see actually the pressure drop right here. You can see we've got basically about 0.94 of a pressure drop from here. This is our ported one. We actually ported a S-tube and sent it to Jeff for analysis so he could actually see it. And this was maxed out where we're almost running out of material. If you cut too much, you actually go through the side of that thing. But as you can see, for you guys that have had our Supercharger intercooler and got the S-tube, we did an excellent job of that. I just want to say that. I'm not trying to tell you guys that had that, you have to upgrade to the new one. I don't want to do that. But you can see actually how much improvement over the stock one. We got it from 0.94 down to 0.34. Keep in mind, 000 would be a perfect straight through tube. Now, this is the new billet one. We've took this even further. This is again based on a 70mm throttle body. Now we're down to 0.21. So to give you an idea, this one down here that we're calling the extended throttle body, this is just a 3-inch tube with a throttle body in it. We have some data showing you how the air reacts around the throttle body. So you can see that is completely a straight tube. You can see the difference right here. We're quite a significant drop. So this is an actual straight tube with a throttle body in it. This is showing you how the air reacts around the throttle plate. Obviously, you could get really crazy and start redesigning the throttle plate for increased airflow. The problem is the small increase, you wouldn't really equate to any more airflow. And again, this is all data showing you how the air reacts around just the throttle plate. I mean, when I tell you we have a ton of research in airflow and how air reacts, I mean, we are not kidding. Our good friend Jeff, again, I want to give him a huge thank you. He's put a ton of time in this. I'm going to show you a model on this. It's a little bit easier to see what's going on, how the air is passing over that throttle blade. Again, on a perfectly straight piece of tube, which just isn't possible. So this is the cast tube, the way it comes from the kit. This is showing you obviously turbulence and then velocity right here. I want to show you something a little bit cleaner here in a minute. It's going to make it obviously look a lot easier to follow. You can see what's going on because there is so much data right here. You can sit and 3D model this and get so much information. It is unbelievable. So this is the very easy to see. This is the cast S-tube just the way it comes. you can see actually the turbulence. This is what they're calling turbulence intensity. It shows you how the air is creating this void here, and it creates basically like a low pressure spot. The air is a null void right here. Now this over here is the ported one. This is the ported one by us, and again, we try and do a good job of porting. There's a ton of time goes into porting these things, and we can pick up some serious airflow, but we've still got a void right here because you can only take so much of that material out. Now this is the billet one right here. As you see, we're taking advantage more of that straight path. There's no void, we've got no turbulence, we've got no intensity turbulence right here, which as you can see in the early ones where we're building that turbulence. The billet one is almost a perfect straight through design. So a little bit more here. This is the factory cast tube without port work. You can see obviously how the air is reacting through there. You can see more of that void I was talking about. It's a little bit easier to see with the colors. You can see the high pressure and low pressure velocity spots. Now this is the ported one, and again, we do a lot of port work on these. It does take a lot of time. We take a lot of material out, and we're trying to change the shape of it. We're not trying to just make it a big massive cavernous tube. We're trying to make the airflow as straight as possible. So you can see when we go over to the same 3D model on the billet one, you can see the relative pressure change right here. We don't have this void. It's a much straighter shot. We don't have the turbulence building in the same areas as the ported one. And again, it's a significant increase in air. Now, again, how I mentioned the supercharger, on the intake side, it wants to be as little restriction as possible. This is new to me, being able to see this in real computer modeling. I've always done it old school way. Take something off, take it to a flow bench, port it, see what the flow bench says, put it back on the car, tune it, see what it did. I got countless hours of doing this, but this allows you to get to that step with computer modeling. And then of course from the computer modeling, we build a 3D printed part, and we can test the 3D printed part in the flow bench the same way, but we can also bolt it to the supercharger and make sure the thing fits. Having something that looks pretty isn't going to be any good if it doesn't fit. So this is just some of the paperwork we have on this testing. And again, there's so much to learn from this, and seeing how the computer can actually show you what is going on, airflow, and you can set it to either pressure or vacuum. Obviously we're doing it with vacuum because the supercharger, this is on the suction side, so it reacts quite a bit different. But again, really good information, and a reason we are doing the billet as opposed to cast. There is some casting companies we talked to, and we could have got this thing cast, but the problem with cast is it's not absolutely identical each time. It then has to be ported, and then you're almost to a point where you may as well just build it, ported, billet right from the get-go. So this is the first one that was done. A lot of the R&D on the machine end was done on this, which means it started as a solid block. As you see by this shape here, the block is roughly this size right here, and from the widest dimensions, it's about this. So when they're building this, they're coming up with a design of where do you hold it, where does it cut, where does the machine, obviously the tool path is showing you how these lines are all made. And then of course the port work, we wanted the port work to be absolutely perfect. Now this is the very first one. There's a few changes to the production version. I'm going to show you in a sec. The production one just came in today. That's why I'm putting this video together. But this is where the machine is actually cutting this out. You see there is a slight difference in color right there, where the machine comes from one side, then it stops and comes to the other. Also, this is our old logo right here. It's not pocketed. It's got like the LHT is solid. As you see in my shirt, this is pocketed. This is the newer version of our logo. This is one of the old ones. So this is one I'm going to keep for our personal project like I talked about. Now, this is the latest one right here. So first off, it's so much shinier because of the tool path. The tool is cutting it slightly different, and it's more even. The machining from one side to the other, there is almost no change in pattern. It's absolutely beautiful. It's got the latest logo right there, as you see. It's got the same pocket as the LHT, but the machining is absolutely beautiful. And again, we could have had this cast. I could have farmed this out to Taiwan and had it made cheaper. I'm proud to have it made in the USA. I'm a big believer of keeping parts local. This is made by the machine shop I've used for 20 plus years. Good friend of mine, Craig, owns that machine shop, but I'm still going through the proper channels to have this done. This isn't a buddy deal. I'm paying to have this done. But again, I try to keep my business local. I try and support the people that I believe are the best in the industry. And this is an absolute work of art. Look at this thing. I'm so excited about this. All we have to do is press in the two pieces right here, and this is ready to go. They're gonna be in the store. I have to message a couple of people that have been really patiently waiting for this, but I'm gonna put this in the store. We have 5 only that's going in the store, and they're gonna be, after that, it's gonna be a pre-order. They take about 9.5 hours to cut. Once this block is in the machine, start to finish, it takes about 9 hours. So there's a lot of material, a lot of cutting has to be taken out. But again, we're not trying to make the cheapest piece in town. We're trying to make something that's absolutely beautiful. And I'm super proud of this. I hope you guys like it. You B-Series Supercharger guys, if you know LHT, you've probably seen us. We've been doing this for 20 plus years with the B-Series Supercharger. We have this. We have the billet throttle body. And of course we have the LHT intercooler, which is what changed the game. So check this out, lhtperformance.com, click on the store. You can buy this, you can buy our other parts, you buy our shirts, and you can see this on an upcoming project. The project, by the way, is going to be called John 99. So thanks for watching, guys. See you on the next video. Don't forget, enjoy your cars.